Core Mathematics for Senior High Schools. Our topic will be algebraic expressions. In today's lesson, we will learn a brief history of algebraic expression, application of algebraic expression in the real world, definition of algebraic expression and examples, and finally, operations on algebraic expressions. Our first question is, if the cost of one exercise book is 2 Ghana cedis, what will be the cost of 15 exercise books? If the cost of one exercise book is 2 Ghana cedis, what will be the cost of 15 exercise books? The answer is 10 Ghana cedis. How did we obtain 10 Ghana cedis? The cost of an exercise book is 2 Ghana cedis, and we are buying 5 of them. That is 2 times 5, that gives us 10. Our second question is, what will be the cost of 1,000 exercise books if the cost still remains as 2 Ghana cedis? What will be the cost of 1,000 exercise books if the cost of one exercise book is 2 Ghana cedis? The answer is 2 Ghana cedis. How did we obtain 2 Ghana cedis? The cost of each exercise book is 2 Ghana cedis. Multiplied by 1,000, that gives us 2,000 Ghana cedis. Now our third question. Can you form or create an equation that could be used to represent the cost of y number of exercise books if the cost of an exercise book is 2 Ghana cedis? In this question, we were not given a specific number of exercise books we want to buy. In mathematics, letters are used to represent values that we don't know. And when letters are used to represent values that we don't know, they are referred to as variables. So in this case, the number of exercise books we don't know. So it's represented by small y or small letter y. How do we get an equation to represent y number of exercise books if the cost of one exercise book is 2 cedis? In the same way as we've done previously, it is the cost of the item or the cost of the exercise book times the number of exercise books. So in this case, the cost of an exercise book is 2 Ghana cedis, and the number of exercise books is y. So it is 2 times y, that gives us 2y. So 2y is our answer. In the junior high school, we did some algebra. What do you remember about algebra or algebraic expression? Let's learn some history of algebra. There was a man called Khwarizmi Muhammad Ibn Musa. In the year AD 800, He was a mathematician and an astronomer of Baghdad, the author of two important Arabic works on arithmetic and algebra. The word algebra comes from the title Algebra wal Mugabala of his book, which contains, among other things, methods of solving quadratic equations. So the name algebra came from a title of a book which contains methods of solving quadratic equations, a book written by Khwarizmi. We're going to watch a short video by Al Jazeera.
1, 2, 3, 4, 5, a little over 5 seconds. It is a great way to be able to understand how to fly an aeroplane, to understand the dynamics of what's actually going on in the aircraft, because I can actually dig into the equations and understand the science behind it. If you want, for instance, to roll the aeroplane, if you double the speed, you will roll 4 times as fast. The fact they discovered it in medieval times is astonishing.
These are some famous mathematicians that we know. We have so many of them, and what is more interesting is seeing ladies among them, like Emmy Noda, and so on. We know of Alan Turing. We know of Archimedes, Pascal, Gauss, Fibonacci, and so many of them, Isaac Newton. These are famous mathematicians, Pythagoras, and so on. Application of algebra in the real world. In business, careers in the business field include banking, financial planning, business operations, and accounting. Algebraic equations using time and interest rates as variables help bankers, lenders, and financial planners calculate loan payments, the value of savings account, and certificates of deposits at a future point in time, and the gain or decline on investment, and so on. In the field of engineering, civil engineering, civil engineers design, inspect, and maintain roads, bridges, tunnels, water supply, and sewage treatment systems, buildings, and other part of major construction projects. These professionals rely on algebra to calculate how much weight roads and structures can hold and their capacity to withstand high winds, earthquakes, snow, and other elements, and so on. In the field of architecture, architects design buildings and draw building plans. Their blueprints depict the length, height, and width of rooms, doors, windows, floors, and other components of a building to a scale. Architects need algebra to convert inch or fraction to feet or yard so that the drawing has the correct proportions and so on. In the field of medicine, medical professionals need skills in algebra to fill prescriptions, administer drugs, and detect potential heart problems and other illnesses. Heart doctors measure cardiac output or the volume of blood the heart can pump by using algebraic equations based on the oxygen levels in the body and heart rate and so on. Now, what is algebra? The definition of algebra is a relationship that is summarized by using variables, usually denoted by letters, example x, y, n, and so on, to stand for unknown quantities whose value or values may be determined by solving the resulting equations. Now, what are we saying? Algebra, or an algebraic expression, has to do with the combination of letters, which are variables or constants, and operations or algebraic operations that includes addition, subtraction, multiplication, and division. So anytime we use letters to represent unknown quantities, we are doing algebra. Now, algebraic expression is an expression built up from integer constant, variables, and operations, such as addition, subtraction, multiplication, division, and exponentiation by an exponent, that is a rational number. So anytime we see a combination of letters with constant or numbers, or without constant, but with operations like addition, multiplication, division, then we know we are dealing with algebraic expression. Now, what is a constant? In mathematics, we use letters to represent values. When the value is a constant, it means that the value is fixed and there's no change. Now, a constant is a symbol, usually a letter, which represents a fixed or non-varying value. Example, in the equation 3 plus m is equal to 5. M is equal to 2. That is 3 plus 2 gives us 5. The letter m has only one value, which is 2. The value of m does not change. It remains 2 so far as the equation is concerned. Now, what is a variable? As the name implies, it varies. So it's a symbol, usually a letter, which represents more than one values. So a variable represents more than one values. Example, in the equation x squared minus 4x plus 3 equal to 0, x has more than one values. When you solve this equation, you have x is equal to 1 or x is equal to 3. So x in this equation is a variable. Now, what is a rational number? A rational number is a number that can be written in the form a over b or a out of b, where a and b are integers, with b not equal to 0. B cannot be 0, because if b is 0, it means that you are dividing a by 0, which is a mathematical error. Now, the set of all rational numbers is usually denoted by Q. The set of all rational numbers is denoted by the symbol Q. When we write an algebraic expression, we can separate or divide into terms. For example, an algebraic expression x squared minus 4x plus 3 has 3 terms. The first term is x squared, or positive x squared. The second term is negative 4x. And the third term is a constant, which is positive 3. So we can separate the terms in an expression using the addition and the subtraction operations in that expression. When separating the terms, the sign, whether it's addition or subtraction, whether it's negative or positive, in front of the number or in front of the number or the letter or the number multiplying the letter is part of that number or that number multiplying the letter. So we didn't write x squared, 4x, and 3. We wrote positive x squared, negative 4x, and positive 3. Now, let's do some practicals. We do a lot of algebra in our lives daily. Let's look at the following example. Example 1. You go to a shop to buy 4 notebooks and 3 pens. If the cost of a notebook is 5 Ghana cedis and the cost of a pen is 2 Ghana cedis, how much will you pay for those items? You are buying 4 notebooks and 3 pens, and each notebook costs 5 cedis and each pen costs 2 cedis. So for the notebooks, which cost 5 cedis, we are multiplying it by the number of notebooks you want to buy. So we are multiplying it by what? 4. And the cost of a pen, which is 2 cedis, we multiply it by the number of pens we want to buy. That is 3. So 2 times 3. Now let's look at the answer. So we normally do such calculations in our heads and pay for the items. But let us look at it in the mathematical sense. In this case, we are going to represent the number of notebooks by the letter n. So n is representing the number of notebooks. P, the letter small p, represents the number of pens you want to buy. Now the total cost can be written as an algebraic expression. So the number of pens we want to buy and the number of notebooks that we want to buy, we can have an expression to represent that. So for the cost of a notebook is 5 Ghana cedis. How many are we buying? We are buying n of them. Plus, the cost of a pen is what? 2 Ghana cedis. How many of them are we buying? We are buying p of them. So now we have a nice expression that will stand in for any number of notebooks and pens we want to buy, so far as the cost of a notebook remains 5 Ghana cedis, and the cost of a pen remains 2 Ghana cedis. It's going to be 5n, or 5 multiplying n plus 2 multiplying p. So we have 5n plus 2p. Now, therefore, if the total cost is capital T, then the capital T is going to be 5n plus 2n. The equation above could be used for any quantity of notebooks and pens that will be bought in that shop, so far as the cost of pen and notebook in the shop remain the same. Now, also from the equation, n is equal to 4. That's the number of notebooks that we want to buy is 4. And p is equal to 3. That is, the number of pens that we want to buy is 3. Then the total cost will be 5 times the n, which is the number of notebooks, which is 4, plus 2 times the number of pens, which is 3. And that gives us 20 plus 6, and that gives us 26 Ghana cedis.